name is Taylor McNeil, and for my science fair project this year, I decided to 3D print a capsule that can be used by people in other countries. 3D printing is the future of technology, and my goal was to innovate the 3D printer by using different types of filaments that can be used in different types of ways that they normally wouldn't be used in. I wanted to 3D print a container that can be used as a delivery system for people in other countries, and when people in other countries use my product, I would want them to essentially try to plant it, and it can grow into different things, and they can use it as food, medicine, or different nutrients. And normally when you try to plant something, you can't use plastic, which normal 3D filaments are made with. So I had to research a water-soluble 3D filament that I ended up using. So for this project, my procedure was first to determine the water-soluble filament and the size needed for the 3D printer. For this 3D printer, the size of the filament needs to be 1.75 millimeters. The second step was to design and create a container / capsule, which I will get into later. Our third step was to utilize different types of softwares that will also help with the design process. My fourth was to print the project. Fifth was to infuse the container or capsule with an additive and then seal it and see how long it will take to dissolve. After that, I would have to submerge that capsule with whatever I put in it and fully into water, find out the dissolve rate, and when I know the dissolve rate, I can determine what size and what thicknesses will end up dissolving the fastest. So I had 3 different phases for this project. My first phase was the design phase, and for this phase, I had to design a prototype, and my prototype can be anything. It can be a basket, it can be a capsule, and I decided to print a heart. So for this part, I utilized Tinkercad and Simplify 3D software to design and create my heart. So I had to use Tinkercad to design what it will look like, and I used the Simply 3D software to size and slice my my prototype, meaning that I would have to size each layer of my heart to make sure that they were all the same size and same thicknesses, or I would get one that's too thick or one that's too thin. The next phase was my setup phase. And basically, during this phase, I had to use the water-soluble 3D printed filament reel and attach it to the 3D printer and prepare it for printing. And for this, I had technical difficulties actually printing with the water-soluble filament because it had trouble sticking to the building plate of the 3D printer. So I ended up just printing the 3D hearts, and for my experimental phase, I ended up using weight to determine how much water-soluble filament I should use to dissolve my product with. So instead of putting this, which is plastic, and submerging it into water to dissolve, I just weighed this on a scale and figured out how much it equated to with a water-soluble filament. So that was my experimental phase, and yeah, that was my experimental phase. And in conclusion, due to the complications of working with the PVA water-soluble filament, it will take more time to learn how to properly build things on the 3D printer using the water-soluble filament. My experimentation resulted in the water-soluble filament not dissolving in warm water, but rather dissolving in boiling water. So I had to end up boiling my water to a temperature of 212 degrees Fahrenheit to essentially get my water-soluble filament to boil or to dissolve. So when my water-soluble filament dissolves, I want it to release something, and I put dye in it to make sure that whatever I used actually came out of the filament, because when other people in different countries use it, I need to make sure after my product dissolves that whatever I use actually works and comes out of the 3D water-soluble filament. So thank you for watching my video, and I hope to see you guys in phase 2 of my project. Thank you.